Welcome to Chapter 1 of Environmental Science, Studying the State of Our Earth. The beginning of your guided notes have a list of vocabulary terms, and the best place to get those definitions is from the glossary in the back of your textbook. It's also best to read your textbook and take your notes from reading the textbook as one way of taking them in, and then using this video to reinforce what you've learned and see if you've missed anything in your reading. The opening case in your textbook, the opening case study, talks about 1 billion fish dying in the Neuse River in North Carolina in 1991. The cause of it was a microscopic free-living organism, Fisteria, which emits some sort of toxin. It has a variety of life stages. They identified up to 24 at one point, and it usually eats algae. But when you increase the nutrients and you increase the number of fish there, it becomes a carnivore. And so this amoeba, like Fisteria, eats the fish carcasses and can form like a cyst. The nutrients they found, this high amount of nutrients was coming from hog farms and agriculture and the suburbs that were putting nutrients into the water. And it cost $40 million loss in seafood sales. What is the significance of this to environmental science? Well, human activities can affect the environment in many complex ways. It can be controversial, like what are the individual interests versus the commercial interests? The hog farm has interests. The individual that's fertilizing his lawn has interests, and then the fish market has interests, and it's not always a clear-cut solution. So as we move on, we look at important terminology, differentiating between the terms environment and environmental science, environmentalism. Environment is the sum of all conditions surrounding us that influence life, which is different from environmental science, which looks at interactions among human systems and those found in nature. This specifies a little bit more about what a system is, a set of interacting components that influence one another by exchanging energy. And before we get to what an ecosystem is, let's talk about an environmentalist, which is different. It's a person who participates in environmentalism, which is a social movement that seeks to protect the environment through lobbying and activism and education. The ecosystem is all part of this course, and we're going to look at all the different biomes and ecosystems, but the ecosystems are the living and non-living components. You need to know the words biotic, which is the living part of the earth, and abiotic, which is the non-living part of the earth. That comes up in your vocabulary definitions. So environmental science offers important insights into our world and how we influence it. Environmental science versus environmentalism we just talked about, but environmental studies, if you look at this wheel here of what comprises environmental studies, it's chemistry, earth science, law, literature and writing, ethics, politics, economics, biology and ecology, toxicology, atmospheric science, so all the things. That's why before you take this course, you need to have a background in both biology and chemistry, because they're such key components of environmental science. And then we will address all of these other things because it really ties into the science and to the humanities. So what are we doing? We're altering the environment. If you look at the left side of this picture, you see a much more natural, unaltered environment compared to the urbanization that's happened on the right side. Humans alter their natural systems. They manipulate their environment more than any other species, and most of the changes have been made in the last 10 to 20,000 years. There's small-scale and large-scale systems. There's biotic and abiotic things that we alter, and things that we do. We convert land, we change the chemistry of the air, the water, and the soil. There's pollution, there's extinction, there's population, there's technology. All of these things are ways that we alter the natural systems. And if we take a look, these are two different examples of urban alteration, and you can see what a difference these two urban centers look like. Environmental scientists monitor natural systems for signs of stress. So we have some big words here. One is ecosystem services. So ecosystem services are what natural environments provide, like clean water, timber, fisheries, and agriculture. Environmental indicators describe the current state of the environment. So they describe the health and quality of the natural systems. They tell us if the environment is either healthy or sick. And sustainability is going to be a key part of this course. We're living on the earth in a way that allows us to use its resources without depriving future generations of those resources. That's going to be a key theme throughout this whole course, sustainability. So what are the 5 key global environmental indicators? Well, table 1.2 is a good one that I want you to sort of look at and why they are significant. And we're going to go through all of these in the next few slides. But if you need to pause and put this in your notes, this is a nice summary of all of those. If we take a look at biological diversity, we're looking at biodiversity, the diversity of life forms in an environment. That biological diversity is then sub-broken down into genetic diversity, species diversity, and ecosystem diversity. And that's all going to come up as your next guided notes question, so you might want to toggle back and forth between these answers. The first one is genetic diversity. And genetic diversity is a measure of the genetic variation among individuals in a population. Populations with a high genetic diversity are more likely to survive. And you learned a lot of that in biology. Species diversity is the number of species in a region or in a particular type of habitat. Species are a group of organisms that are distinct in form, behavior, and biochemical properties, and the most important thing is that they can breed and produce fertile offspring. Then we have speciation versus background extinction. We have a rate at which extinction is happening in the background at all times, and we're sort of accelerating that extinction. And humans and our effects on the environment are reducing species diversity. We're going to spend a lot of time talking about extinction and what's going on with that. And then finally we have, and this is a nice image here, of diversity, of different species diversity. And then ecosystem diversity, which is a measure of the diversity of ecosystems or habitats that exist in a particular region. The more diversity of habitats we have, the healthier that region is. The second thing, if you go back to your guided notes 5, what are the 5 key global environmental indicators? Well, the first one was biological diversity, and we just went into the 3 subgroups. But then the second one is food production. Our ability to grow food to nourish the human populations. And we use science and technology to increase the amount of food we can produce in a given area. We look at human population and we look at livestock and what's going on now. What is the impact of the number of people that we have on this earth and our ability to provide food for them. And we're going to spend a good whole unit on agriculture and food production. The third of the 5 key global environmental indicators is going to be average global surface and carbon dioxide concentration. This graph right here is looking at grain production. Just to backtrack a second, so per capita grain production, how much can we produce per person? We'll spend a lot of time with this graph going into the agriculture unit. Average global surface temperatures and carbon dioxide concentrations, where we're looking at greenhouse gases, gases in our planet's atmosphere that act like a blanket trapping heat near the Earth's surface. The most important greenhouse gas is carbon dioxide. It's also the one that occurs naturally. And then we have many that are anthropogenic. That is a really key word in this course as well. So sustainability we saw, and then anthropogenic, which is caused by human activities. The greenhouse effect, and we're looking at this graph, which is greenhouse gases versus global temperature. As the greenhouse gases increase, so does global temperature. We will spend huge quantity of time looking at this graph and this data and discussing global warming. The fourth thing for the 5 key global environmental indicators is human population. The current human population is about 7.1 billion. Over 1 million additional people is added to the earth every 5 days. Go ahead and take that statistic in. Over 1 million additional people is added to the earth every 5 days. At least world population it's grown, but it's slowed down since the 1960s. If you look at predictions of where we're going to be in the year 2050, there's the high prediction, which is above 10 million, and then the low prediction, which keeps us just a little above 7 million. So, or 7 billion, excuse me, not million, 7 billion. So, I guess we will wait and see where that ends up in the next 30 years or so. And then our fifth one is resource depletion. As the human population grows, the resources become increasingly depleted. Some natural resources are finite and cannot be renewed or reused, and then other natural resources can be recycled. We also have resource use per capita. So what is the resource use per person? And how is that significant? How is it significant? How much is used per person? Resource depletion is development and improvement in human well-being through economic advancement. So as economies develop, resource consumption also increases. And if you look at in developed nations, we use the bulk of automobiles, meat and fish, total energy, and paper. And then in developing nations, they use significantly less. You have to keep in mind that developing nations have a high population, which is why they might have a higher percentage of the meat and fish. And human well-being depends on sustainable practices. In order to live sustainable, environmental systems must not be damaged beyond their ability to recover. Renewable resources must not be depleted faster than they can regenerate, and non-renewable resources must be used sparingly. So if we look at this idea of being sustainable, look at anthropogenic. Anthropogenic is derived from human activities. What are some examples of anthropogenic carbon dioxide in the last 2 centuries? Well, one is the combustion of fossil fuels, and the second one is the net loss of forests and other habitats that would normally absorb that carbon dioxide. If we're looking at living sustainably, these are examples of living sustainably. So, not damaging our environmental systems, not depleting our renewable resources, and using sparingly our non-renewable resources. Human well-being depends on this. Sustainable development is development that balances current human well-being and economic advancement with the resources management and benefit for future generations. And this is an example of something that we can do that's sustainable. We can bike instead of using automobiles. And the last thing we'll look at in this video is defining human needs. So it differs for different individuals. People in developed nations might say that they need electricity. People in the developing world have never heard of this modern convenience. So it differs for different individuals, but there's basic human needs that all human beings need. We all need air, we all need water, we all need food, and we all need shelter. These are all the things that we need. This idea of biophilia, the love of life, which is a need to make the connections that humans subconsciously seek with the rest of life. We have it in us to connect, not only with the environment, but with each other. And those connections are sort of defined into a basic human need. This is where we'll end the first part of Unit 1, and then we'll continue on with the second video.